Here are the step-by-step solutions to the worksheet from yesterday. Please take a look at them. I do want to point out for B, though, right away there is no work to be done. It is a special case. We have an absolute value is equal to a negative, which can never be true because that would give us a positive would equal a negative. That's never true, so no solution. If you did end up like setting x plus 2 equal to 8 or negative 8 and solving, just be sure to check your solutions. You're going to find that neither of them are going to work. And if this is a little bit hard to see, for A, x is equal to negative 2 or 14. Again, notice the way I have these written out. As soon as I go to rewrite them, I'd no longer use the absolute value bars like in C. I set negative 8x. I don't turn that to a positive. I keep what's inside the absolute value bars the same. So I set negative 8x equal to a negative 64 or negative 8x equal to a positive 64. Likewise for D, I take negative 7x plus 4, set that equal to a negative 18, or I set it equal to a positive 18. Now for E, we have to be careful here. We definitely want to check both solutions because one that we get, x equals 6, is the only one that satisfies the equation. The 4/3 will not. Now here's what's interesting too. If you go to Desmos and you just graph y equals the absolute value of 4x plus 4, and then you graph y equals 8x minus 20, and look for the points of intersection here, you're only going to see it intersects at one point when x is 6. So that's how you could use Desmos and graph these two sides separately to find out. So take a look at the rest of these. Likewise for H, we get two solutions here, but 15/4 is the only one to satisfy. The 1/2 would give us a negative value over there on the right. All right, on the back, we have the inequalities. So just look here. Again, we have to isolate the absolute value. This is a less than, so we set n plus 9 in between, or it is in between the negative 1 and 1, and then we just solve. But for B, we have to first subtract 28, and then we set this as a greater than, so we're beyond. So negative 7x is less than a negative 35, or negative 7x is greater than 35. Take a look at C. That's another one that's beyond. And D, that would be in between, as soon as we subtract the 5 from both sides. E is already isolated, so that's a beyond statement. F is an in-between statement, but we have to first divide both sides by 2. So please correct your homework and let me know if you have any questions. All right, what we're going to take a look at today is identifying whether a graph or a list of ordered pairs is going to be a function, and then also stating the domain and range. So let's go through these here. So a relation is just anything, any set of ordered pairs. So again, in the set brackets, we could be looking at a 1, -2, a 3.5, and a 1, 6, whether we can actually plot these points or not. We could actually be looking at maybe a square root of 3 and a -4, and then maybe just a 0, 2. So any set of ordered pairs. They could be anything. Now to identify the domain is just the set of all the x values of a function. It's answering the question, how far left to how far right the graph reaches. What are the x values? How far left to how far right? The range is a set of all y values of a function. And again, guys, pause the video at any time you need to. The range answers the question, how far down does the graph reach on the y-axis to how high up? Now, not everything is a function. Given a relation, we list the x or y values in order and only once. So if we're trying to state the domain and range, if we're given just a list of ordered pairs, we list the x or y values in order and only once. Given a graph, we're going to use set or interval notation, and I'm primarily going to use interval notation. But then we also, like I was getting to, have to determine whether a function or a relation is a function. So here's the actual definition of a function. It's a relation in which each x value is paired with only one unique y value. What does this mean? It just simply means all x values must be different. So if we're looking at a list of ordered pairs, every x value cannot be repeated. Graphically, a function, if you guys recall, must pass a vertical line test. A vertical line can only pass through a function once. All right, so get ready to make a coordinate plane. We're going to plot some points and graph a line. So you could do this right on notebook paper if you have a ruler. Here I'm giving you a list of ordered pairs. We want to state the domain and range of each relation, then graph the relation and identify whether it is a function or not. So pause the video, go ahead and plot those 5 ordered pairs. All right, so the first one at 9, 0 is going to be right here. Next we have -2, 5 right up here. Then we have -1, -3. We have 4, -6. And then we have 9, 3. So those are our 5 points. In order to state the domain, because we're given a list of ordered pairs, we're going to list the values of the domain. So if you underline all the x values, we're going to write them in order, and if any repeat, we just write them once. So the smallest x value is going to be the -2. After that, we have -1. Then we have a 4, and we have 2 9s, but we just write it once. So really what's happening here is here we have the 1 point located at -2. We have another point located when x is -1, right here at 4. But then we have 2 points here at x equals 9. Now for the range, we're going to list all of the y values in order, and if any repeat, we just write them once. And again, we have to keep them, it's a set, so we need those squiggly set brackets. So the smallest y value is going to be -6. Just looking at the graph, that's right here, -6. Next, as we climb up, we have another point here at -3, so that's our next y value. All right, after that, we have a 0. So we would have a point right here at 0 on the x-axis. As we keep climbing up, we have another point here at 3. And then our highest point here is at 5. So we didn't have any repeat. All of our y values showed up separately. So is this a function? Well, we did have 2 x values that were the same when we looked at 9, 0 and 9, 3. So if I were to draw a vertical line, whether it's solid or dashed here, it's going through those 2 points twice. So that's the vertical line test. Because it passes through 2 points and not just one, definitely not a function. Because think of any electronic device. We know it's working if it's functioning, right? So let's say we had an input of 9 and we get a 0. Then we have an input of 9, like we're pressing 9 on a calculator, and all of a sudden we get a 0. That should happen every time. But now we're hitting a 9 and we're getting a 3. You can't have 2 different results from hitting the same button. So it's not functioning correctly. All right, for B, let's go ahead, pause the video, get this in slope-intercept form. And then we want to graph this. All right, so to solve for y, I'm going to move 8 to the other side. So I'm going to have -5y equals, I'm going to go ahead and put the -2x and then the +3. And then I'll just show right now, I'm just going to subtract an 8. So I get -5y equals -2x. 3 minus 8 will give me a -5. Next, I want to divide everything up here by -5. So now I'm going to get y equals +2/5 x. -5 divided by -5 is a +1. So let's go ahead and graph this line. If you remember how to do that, just pause the video and go through it again. Our y-intercept is 1 on the y-axis. I have a slope of 2/5. So I go up 2, 5 to the right, and I can repeat this process. Or keep in mind, I can also go down 2, but then 5 to the left. As long as the points line up, we know we're doing this correctly. So I'm going to draw my line going through these points. Okay, so here is my line. Next, we're going to state the domain. So how far left? So if I'm at any x value going to the left here, I have points on the graph that would have those x values. And if I keep going to the right forever, I have points on the line that would match those x values. So this line goes on forever to the left and to the right. So we would say all real numbers or -infinity to infinity is the domain. I can't list all of them like I did in the last example. There's just infinitely many. Now my range is how far down on the y-axis to how high up does this reach? Well, this line is also going down forever. It's going down and to the left forever. It's going up and to the right forever. So any kind of line that isn't strictly vertical or horizontal is going to have domains and ranges of negative infinity to infinity. So on this next page, this is a printout of just some examples. We're not going to do all of them, but just identifying domains and ranges of graphs. All right, so we're looking at the set of all real numbers because we have the graphs as continuous here for the most part. And then we're also going to identify whether these are functions or not. So let's just go ahead and look at number 1. Now, the second page of this, what I'm passing out in class, will have a back to it, and those will be your examples. So I have that along with 6 review problems. That will be a separate PDF in case you want to print those out. You don't have to recreate the graph. All right, so here, my domain, I'm just going to start on the x-axis and ask, does the graph go to the left forever? So if I move along the x-axis this way, is that graph still moving to the left? It is. Even though it's moving down and to the left, it's still going to the left forever. So I'll put an arrow on the end. As I move to the right, does the graph go to the right forever? Not quite. It does go to the edge of the coordinate plane that's here, but it stops. So my domain goes to the left forever. So I'm going to start that with a negative infinity. But then the furthest right it goes is to 5, but it's including the 5. So we have negative infinity to 5, and then parenthesis and bracket. Now the range, how far down does the graph go? Well, it's going down and to the left forever, so it's going down forever. How high up does the graph go? It only goes as high up as the y value of 2. So again, we always want to go from smallest value up to largest. So if it's going down forever, keeps decreasing without stopping, it's going to be negative infinity up to positive 2. That 2 is included, so there is our interval notation for the range. Let's go ahead and look at number 2. Again, if I look at the x-axis, I can't just start anywhere. My graph is only showing up how far left does it go right here, how far right does it go right there. Now, because I have an open endpoint here, I'm going to put one there, and I'm going to put an open endpoint there. So my domain only goes from what number to what number? If you're saying -5 to -2, and neither one of those are included, so I have parentheses around them. Now my range only goes, I could start right here at the origin because it will go down just to -4. And how high up does it go? It keeps climbing up until we get to +4. So my range is going to go from -4 to +4, and again, I'll keep parentheses around them. Let's go ahead and do number 4. All right, so my domain, how far left does it go? Even though I move along the x-axis and it looks down here like it's going to stop, but above it, it keeps going, so I keep going. So my graph does go to the left forever. As I go to the right, I'm only going right here to 3, but I'm included in that. I'm on the graph. So my domain is going to be what, guys? Negative infinity to 3, but I'm including it. The range, you guys go ahead and give this a try. How far down to how high up? Pause the video. So this is going to go all the way down just to -2. Notice there's a closed endpoint, so I include it. How high up does it go? There is an arrow, so this is going not only to the left, but up forever. So in this case, I'm going to start at 2, but include it, and then we go to infinity. And let's try, I want you guys to actually try number 5. Pause the video and give that a try. All right, here my domain. I could start at the origin and then just ask how far left does it go. And it looks like it goes as far left as -4, but there's an open endpoint. How far right does it go? Right here to 3, there's a closed endpoint. So my domain is going from -4 to 3. The 3 is included, but the 4 isn't. The range, how far down does it go? We would think right to here, but on the left side over here, it still goes down right to here, right to -5. How far up does it go? Right here. And that graph is continuous there. I could still go right up to it and include that point, so I put a closed endpoint. So my range goes from -5 to 2. The 2 is included, but the 5 isn't. All right, I do want to talk about number 9, because there aren't any asymptotes drawn in here or any dotted horizontal lines. So what's happening is like this end, we're not going to assume that it just flattens out. It is slowly going to go up this way. So unless you see the actual dotted lines draw in, we can assume that it's still gradually going down forever. So pause the video and answer this. Our domain, how far left does this go? Well, this keeps going to the left forever. How far right does it go? It keeps going to the right forever. So our domain, negative infinity to infinity. How far down does this go? So it's going gradual, but it is still decreasing forever, and it's increasing forever. So our range still goes up forever, down forever. So negative infinity to infinity this way. All right, so that was a lesson over domain and range looking at a graph. Let's go back and identify if these are functions or not. So if I look at the first graph here, if I were to draw a series, the paper could stay up here. If I were to draw a series of vertical lines here, every vertical line is only passing through that what's graphed here in black one. So yes, this is a function. In 2, again, a series of vertical lines would pass through everything once, so this is a function. But for number 4, I'm good as I'm over here, but as soon as I meet here, we're passing through the graph here and here, likewise over here and here, so this does not pass the vertical line test. So I'm going to say not a function. 5 would be a function, passes the vertical line test. And likewise for 9, every vertical line would only pass through the graph once, so this is a function. All right, so what I'm assigning in class today is going to be, and I have this as a separate PDF, I have these 2 review problems, 4 more equations to solve, and then on the next page I have more domain and range, but do all 9 of these. So you could just pause the video to answer them, or like I said, I have a separate PDF that you can print out and write right on the worksheet. Let me know if you guys have any questions.